Let me show you the steps to solve second order homogeneous differential equation. If I have the equation y double prime minus 3 times y prime plus 2 times y equals to 0. Step 1, the first thing that I'm going to do here to change this equation into differential operator form, which is d square minus 3d plus 2 equals to 0. For the second derivative term, I put d square, and for the first derivative term, I put d. And I don't have any derivative term here, and therefore don't interrupt 2. Put it as it is. D square, d are called polynomial operators, are differential operators. But let me prove it how I got these operators. Take this equation, which is y double prime minus 3 times y prime plus 2y equals to 0. For the second derivative term, y double prime, can I write d square y or dx square? Yes. For the first derivative term, can I write dy or dx? Now take y common here. So y will become 0. And now we're left with only d square or dx square minus 3 times d or dx plus 2 equals to 0. And that's how I got the polynomial operators. Step 2, to find the roots of the above equation. Since the above equation d square minus 3d plus 2 equals to 0 is able to be factorized, and therefore simply do factorization method to have d square minus 2d minus d plus 2 equals to 0. Moving ahead, and finally we got d sub 1 equals to 2 and d sub 2 equals to 1. These are the roots that we got in step 2. Moving to step 3 here. Step 3. In step 3 we have these 3 rules here. If the root is real and d sub 1 is not equal to d sub 2, then you're going to use this formula y equals to c sub 1 times e to the d sub 1x plus c sub 2 times e to d sub 2x. Rule number 2. If the root is real and d sub 1 equals to d sub 2, then you're going to put this formula y equals to c sub 1 plus c sub 2 times x into e to the d sub 1x. Rule number 3. If the root is complex root, t sub 1 plus minus I t sub 2, then I'm going to use this formula y equals to e to the t sub 1 into c sub 1 times cos t sub 2x plus c sub 2 times sin t sub 2x. But when you look at here, d sub 1 equals to 2 and d sub 2 equals to 1. D sub 1 is not equal to d sub 2. And therefore I'm going to take this equation here, y equals to c sub 1 times e to the d sub 1x plus c sub 2 times e to the d sub 2x. Substitute the value of d sub 1 and d sub 2. 2 is the value for d sub 1 and 1 is the value for d sub 2. This is the final answer for step 3. Y equals to c sub 1 times e to the 2x plus c sub 2 times e to the x. But let's suppose d sub 1 equals to d sub 2. Let's take d sub 1 equals to 2 and d sub 2 equals to 2. When you look at here, d sub 1 equals to d sub 2. And therefore I'm going to take this equation. Y equals to c sub 1 plus c sub 2x into e to the d sub 1x. Since d sub 1 equals to 2 and d sub 2 is also equals to 2, and therefore I'm going to take d sub 1 here. Just substitute the value of d sub 1, which is 2. So this is the final answer for step 3, y equals to c sub 1 plus c sub 2x into e to the 2x. But let's suppose we have complex roots. Let's say I have an equation y double prime plus 4y prime plus 13 equals to 0. Let me apply the polynomial operators d square plus 4d plus 13 equals to 0. When you try this equation to simply factorize it, it is not possible to do simple factorization. Therefore, at this stage, we use quadratic equation. We're going to use quadratic formula here, which is minus b plus minus b square minus 4ac under the root over 2a. The value of a is 1. There is 1 in front of d square, but we normally don't write. And b is 4 here. C is 13. Just substitute these values here. This is complex form. And when you compare here, t sub 1 is minus 2 and 3 is t sub 2. And therefore I'm going to use this equation now. Y equals to e to the t sub 1 into c sub 1 times cos t sub 2x plus c sub 2 times sin t sub 2x. Just substitute the value of t sub 1, which is minus 2, and t sub 2, which is 3 here. This is the final value in step 3. Y equals to e to the minus 2 into c sub 1 times cos 3x plus c sub 2 times sin 3x. These are the 3 steps in procedure to solve a second order homogeneous differential equation. Let me do some tutorials of second order homogeneous differential equation in upcoming lectures.